everyone, and welcome to another interesting lead code problem, which is threesome. But before watching this problem, I would recommend you to watch two-sum problem in order for you to understand this problem clearly. So let's start understanding the problem. The question says, given an integer array nums, return all triplets num_i, num_j, num_k such that I is not equal to j and I is not equal to k and j is not equal to k, and the num I plus nums j plus num k is equal to 0. So what the question asks us, you have an array and you have to return three elements such a way that when you add those three elements, the sum of those elements should be 0. This is the first condition. The second thing is the I, J, and K element should not be same. Meaning, like for example, here, okay, the question says like I is not equal to J and I is not equal to K. But if you will see here, I, this is the ith element, I is not equal to J and I is not equal to K and the J is not equal to K. Meaning that there shouldn't be any repetitions of the elements. Notice the solution set must not contain duplicate triplets. So the elements of the triplets should be unique. You are not like using the same triplets again and give the another triplet the same, like duplicate triplet should not be there. So let's see how we can solve this problem. All right. Okay, the first thing that you need to do, as you have seen in the question, you don't have any such condition where it says that you have to take all the consecutive elements. So you don't have any that condition like that. So that means there should not be any contiguous element requirement here. And that means if that requirement is not there, the first thing that you should think of is to sort the array. So the first thing that you are going to do is you need to sort the array. This was our original array and this is the sorted array. Okay, the brute force approach will be, you will take this element and then with respect to this element you take all the combination of each other, the next element, and then you will take this element and then each combination you are going to try, right? So but we are not going to, and that will take o n cube element, o n cube complexity, because we need to traverse this array three times if we are going to go with the brute force approach. What we are going to do, we will go with the two pointer approach and the two sum approach. So these are the two things we are going to use. We will use two pointer approach and we are going to use two sum approach. So if you have not seen two sum problem, please go and watch two sum videos so that you can understand this problem clearly. All right, so how we are going to do that? First of all, we will the outer loop should take the elements for the ith position. Okay, so we will fix a value of I. The first thing, we are going to take one element, one value of I, and with respect to this I, we are going to check the value of j and k, such that when the value of j and k adds to this I value, they should give you the result equal to 0. So the ith value is fixed and j and k values are going to change, right? And then I'm going to proceed to the next I element, and with respect to that I'm going to check that. If the question was still here, it was not that much difficult, but the difficulty arises by encountering this condition, which is, it says there should not be any duplicates. There should not, the solution set must not contain duplicate triplets. So there should not be any duplicate sets, right? So how we are going to achieve it? All right, first let's just forget it and see how we are going to achieve the result. So, okay, all right. So, as always, let's try to make the table and see how we can understand it properly. All right. So, first, I'm going to take the value of I, which is -4, okay, which is going to fix, right? That is at the start, this value is not going to change. And the value, and I'm going to start the left pointer that is pointing to the next element of I, and the right pointer is going to point to the last element of this array, because I need to check the rest of the array for I and j values, right? Okay, let me delete, so just to make it a little bit neat. All right, so I'm going to start traversing. So the I mean the left pointer should start from the value next to the I. So if the value if the I is pointing to the zeroth element, L should point to the first element, and right should always be at the end. So I need to traverse the L and R to find such two elements, such that when they add to -4, they should give the value 0, right? Okay, so let's see. If I take -1 here, and the right one is 2, okay? All right. uh, and when you will write, and when you will find the current sum, you will see what is the current sum. So -4, -1, -5, and this is 2, so it will be -3, right? And then we are going, as we were doing in the two sum problem. If the current sum is less than 0, if the current sum is less than 0, then we need to increment the left pointer. Otherwise, if the current sum is greater than 0, if it is greater than 0, then I need to increment the right one. So this is the condition: increase left or increase right. Okay, and why I'm doing this, why I need to increase the left pointer? Because we know that the array is sorted and all the elements on the left side are less, and if I need to increase my sum, I should move in this direction to get the maximum values. Whereas if the value or the total result of the sum is higher, then I should need to move backward to decrease the values. Understand? All right. So when I see it is -3, that means -4 will remain same. And which pointer I should move? I should move my left pointer. So when I move my left pointer, it is pointing not here. Now it is pointing here. Okay, so it is still -1, and then this value is 2, so you will get the same result, -3. I'm going to tell you some extra information that is like after you understand this thing. All right, so -4, and again I need to move my left pointer, which is here. So this value becomes 0, and my right pointer is still at this point. So when you add this, it will give you -2. Still it is less than 0, so my left pointer should move here, and then it is -4 and 0, and this value is 1. Okay, and -1, -4 and 1, it will give you the value. I mean, sorry, here it is 1. The left pointer is 1. This is still the same. So 2, 1, 3 and -4, so it is -1. But by here, the condition left is less than right, like we need to see left is less than right, will like the loop is going to terminate because the left already reaches the right one. So we have seen that none of like by using the value -4, we did not get any good solution that will give us the zero value. All right, so let's erase these things. Okay, and let's try to do the execute the same thing by using the different value of I. Okay, so we have already checked the first value of I. So oops. Okay, all right. No. All right, just leave it. Okay. So now I'm going to check, like, so this element is already crossed. We cannot use this element. Now we can use the I value as -1. So my I is -1, which will remain be -1. And my left, as I mentioned, it will point to the next value, right? So the left will be here. So the left will be pointing to -1, and my right is pointing to this value, right? So I mean, sorry, sorry, my bad. The right will point to this value. Okay, all right. So when I write minus 1 is my ith value, it is getting very dirty, but I'll try to use the same things to explain it better. All right, so the right is 2. So if you see here, minus 1, this is minus 2, and this value is 2, it will give you the value 0, right? So I'm going to add the first triplet here. All right, then then the second thing that you need to remember is like, if all right, I will explain that thing later as well, because then it is going to be more confusing. Okay, so now what I need to do, I have to, because we have already tested this, right? So I'm going to move to the left will going to move here at the place 0, and my right is going to move at the place 1. And if you will check that the pair minus 1 with my, like, the value of I is minus 1, and the value of left pointer is 0, and the value of right pointer is 1, it will also give you the result 0. So you are going to add this. So what I was telling you about the extra information, let me explain you that thing. The thing is, to avoid duplicates, what do we need to do? Meaning we must need to avoid duplicates, right? So for example, although I cannot explain you in this example, because we with respect to j and with respect to k, we do not have any duplicates, right? But we need to make sure of the conditions. Okay, let's start coding and then I'll explain you. I hope you will understand it while I'll be coding. Okay, that will be more clear to you. All right, so the first thing that you need to do is you need to initialize an array which you call as a result, which will hold the result value, okay, which is at the start will be a blank array, right? So you will start the outer loop for I in range of length, or you can say for I in enumerate nums. So you can get the index and the value as well. The first thing that you need to check is, because we cannot use the same value again, right? Okay, before that you need to sort that as well. So nums dot sort is going to sort the array. Okay, all right. So now you need to make sure one thing, and that thing is that the value for I should not be repeated, right? So for example, if you use one value, like I is, for example, minus 4 is coming twice, and you have used minus 4 once, then you should not use that minus 4 again, because at the same place you cannot use the duplicate value, right? So for that thing you need to check this thing, that for sorry, if I is not equal to 0, and meaning it's not the first element, and the value, whatever the value, is equal to the previous value of I. Okay, why we need to check this not equal to, otherwise this will give you an out of bound error. Okay, so you need to check if I is not equal to 0, meaning this is not the first time, the I must be at first, second, or whatever the next iteration is, and whatever the value of I, it should not be same as the previous value. Okay, then if it is same, then don't do anything, just continue until you get a different value. Okay, all right. Now you, by this time you are like, you are sure that whatever the values of I you are getting are unique. Okay, now we need to set our left and right pointer. So my left pointer is going to point I plus 1. Okay, and my right pointer is as always going to point at nums minus 1, length of nums minus 1. Okay, now you are going to put the while loop as we did in two sum problem. So while left is less than right, okay, you have to first calculate the sum. So my 3 sum is equal to, okay, the whatever the I value is, which is actually in my val variable, plus nums of left plus nums of right. Okay, all right. So now I'm having the total sum of these values. Now I need to check if this sum is equal to 0. If 3 sum is less than 0, that means I need to increase the value, right? To increase the value, I need to add L is equal to L plus 1. Else if 3 sum is greater than 0, meaning I need to decrease my right pointer because the value is greater than what is the required. So I need to decrease my right pointer, right minus 1, right is equal to right minus 1. Else, meaning that it is same, 3 sum is equal to 0. All right, so if it is equal to 0, we need to append result dot append. Okay, and what do we need to append? The variable, the value, which is the value of I, and nums L, which is the value at place at the left pointer, and then nums at right. Okay, but we need to make sure that if the left pointer, okay, the j value, just imagine the j value, if the j value is getting same for the next iteration, then just pass that, because we don't need duplicates. If that duplicate condition was not here, our program was complete by this time. But this duplicate condition make it a little bit more complex. And what do we need to say? What I'm trying to say, if for example this was 1 and this was 1, so when j was here I get 1. I don't want to get j equal to 1 again, right? And for that reason, what you need to do, you will make a loop while left is still less than right, and what else? Nums of L is equal to nums of L plus 1. If these two values are same, then do what? Just L is equal to L plus 1. L is equal to L plus 1. Okay. And the same we need to do. I think we can even do it in one line. No need to write it in two lines, just to look it simpler. Okay. So the same thing we are going to do for the right pointer, because we need to make sure the values at the right pointer are not matching with the previous one. Okay, and you will say num while left is less than right, and nums of right is equal to nums of right minus 1, right? Okay, I mean, yeah, nums of right minus 1. Then what we need to do, r is equal to r minus 1. This is what we need to do. This is in case for the while loop. Otherwise, just come and do the updation. L is equal to L plus 1 and R is equal to R minus 1. Okay. So that means we have already taken those, we have taken the L value and the R value. So we need to, otherwise, because we have already taken those values, we don't need that left value, we don't need that right value. So we are just updating the pointer. And at the end, what you need to do, you just need to return result. I wish I will not get any errors in it. Let's see. This is not possible that we run the program global name val is not defined. Yeah, because for I in numerate, oops, for I comma val in enumerate nums. Okay. And the output, okay, yeah, because here. I wish it will be executed, and let's submit it. Please don't give me any error. Wow! So you can see that the program is quite efficient. We are getting 80.46%. My program is efficient than 80.46, faster than other programs. All right, so what was the error? Just let me explain it to you. So for example, if this return statement is not aligned with this for loop, it means that we are returning at this point, which is not true. So it is going to return by -4 value, understand? So you need to make sure that these return statements should be properly aligned to your program of code, because this mistake sometimes I may make when you are writing a long program. You don't realize that the indentation of your return is proper. Okay, so I hope you understand this. The video gets a little bit long, but I hope you understand it. Then it's fine. Until, okay, take care, and until next time, I'll